Okay, one thing that's important to understand about our cost function is there is no minimum value to the cost function. If I make more objects, it will cost more always. However, one of the things that we're very frequently interested in is what is the minimum average cost or average cost per unit. So if I take my total amount of objects and I figure out how much they cost me, and I divide by how many I made, that is my average cost. Now, so what's very important to uh, learn and understand is we can find that lowest value on the average cost function in a couple of ways. Now, according to calculus, I should be able to take its derivative and set it equal to zero, but sometimes that's more difficult than you would think. Another very useful technique is by setting the marginal cost equal to the average cost. And what you'll notice is when my marginal cost and average cost cross, that is the lowest value of the average cost per unit. So we're going to do that. So again, average cost is all of my cost for making so many units divided by how many units I made. And my marginal cost is the derivative or the cost per unit to make the next one. And they sound very similar, but the big difference is marginal cost never includes your startup cost, and those can be monstrous for a manufacturing industry. So let's take a look at how that works out in a problem. So here we have this cost function here. And this is a small furniture manufacturer, and they estimate the cost in dollars producing Q units of a particular chair each month by this given polynomial function. How many chairs should be produced in order to minimize the average cost per chair? So the first thing I'm going to do is write the average cost function. So average cost per function is my total cost. That's my total cost, and it equals this amount, 10,000 plus 5q plus 0.01q squared, and we divide that by how many units we make, which is q units, and that is my average cost. My marginal cost is equal to the derivative of the cost function. So notice when we take the derivative of the cost function, the first term, no matter what, and that is my initial value of cost or my startup cost, those are not impacting the derivative at all. It doesn't matter if it's 10,000 or 10 billion. So that's important. So the rest of my derivative, uh, take it term by term, and then we're going to set these equal to each other. So we've got average cost over Q equals marginal cost. And what I'm going to do is multiply both sides by Q to clear that fraction. I'm just going to write everything in black now. And I have 10,000 plus 5Q plus 0.01 Q squared equals 5Q plus 0.02 Q squared. And what's really interesting here is this 5Q and this 5Q can eliminate each other by subtracting it from both sides. And then I'm going to move my Q squareds over to this side with subtraction, leaving me 10,000 on the left and 0.01 Q squared on the right. I'm going to divide by 0.01, which is in essence moving my decimal place over two places. And that's going to give me Q squared. I'm going to take the square root of both sides. I will not have a plus or minus answer because there's no such thing as negative chairs. So when I take the square root of that, the positive root is 1,000, and that is the number of chairs that must be produced in order to minimize the average cost of this function.